All righty. So now, excuse me. Y'all are watching this after your first exam, so congratulations for making it through that. I am sick right now. Um, but we are going to power through this last section of chapter 1 together. And then we'll move on to chapter 2. And I think that will be all of for exam 2, which I know is already scary to talk about. It's a 6-week class. Things have to keep moving. So 1.8 is working with functions, modeling real world relationships. So this doesn't have a step how to do it like we had for completing the square and things like that, or a formula like the quadratic formula. So this is kind of definitely practice makes perfect with these. And yeah, so this is all about word problems, but I said world problems, which also is kind of funny. But kind of along the same lines of what we've been talking about. I think at 1.7, we're going to be having units now in our problems. And we're going to be taking what we know about random things that I'm not going to explicitly tell you. Things that I expect from you to know. The perimeter of a rectangle and a square, the circumference of a circle, and the area of those 3 shapes, and the area of a triangle maybe. And then also volumes, mostly the volume of a cube or a rectangle, right? Length, width, height, it's not a word. And also volume of a sphere and maybe a cylinder. And those you can easily look up online. Remember, your exams are open book, open note. So if you just have a little note page of all those useful things, I think also in the e-textbook, in the very, very front, there might be a volume and thing. There usually always is in the calculus one. So speaking of calculus, am I recording? Okay, good. Speaking of calculus, this is the beginning section of what calculus problems are called optimization, where we do some calculus and we find the max and min. We can do that in calculus in a really quick way. And if we're optimizing, so I want to optimize profit. So I want to find the maximum. So I want to minimize my cost and stuff like that. So this is kind of setting you up to do those problems in 122, 141, and so on by just working on making the functions themselves that you would then have to do calculus with. Okay, so this is all just kind of coming up with functions and things that we're told. So the research first going to kind of start off pretty linearly, and then they're going to grow and grow. Okay. So a company manufactures baseball caps. They charge a fixed fee of $500 for setting up the machines. So I like to go through these and highlight things. We're choosing kind of a berry color since it was 4th of July yesterday. So just $500 for the setup, right? Not talking about materials or anything else. And $8 for each cap produced. So the time the machine runs, it just kind of calculates that already. If you ever taken an accounting class, there's FIFO and LIFO and stuff. I once saw a tweet that the guy that tutored Trevor Lawrence, the Clemson football player, about for an hour and the difference between LIFO and FIFO, and he never got it. And now he's going to make more than that guy for the rest of his life. I just thought that was funny. So we're going to find a model for the cost of purchasing X number of caps. So X will represent the number of caps, and let's call it C of X is the cost for X amount of hats, of caps, right? So we're not looking at profit or revenue or whatever, we're just looking at cost. So cost, I'm going to have, no matter how many caps I make, I know I'm going to make that 500. So if we go over, it's sometimes nice to make these little charts. So if I make 0 hats, I'm definitely going to pay that 500. Okay, if I make 1, I'm still going to pay that 500 and then another $8. So I'd have 508. So that means for 2 caps, I would have to pay 2 times 8, 16 plus that 500. So I get 516. And then you can see from there that my initial value is 500. So this is just, we would say that this is can be modeled linearly. So if we look at like a common difference, it'd be nothing there but 8, 8, blah, 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 right? So 8 would be our slope, right? All right. And you can always double check it by putting in a few of these numbers, right? And another thing is I kind of talk about unit conversion a lot. I took physics the same time I took calculus and astronomy. That was fun. And a big thing that we did in our physics class was unit conversion. And I think that's really helpful for figuring out what that number should be. If you remember that like chocolate car problem, your common difference was 17, but it was 17 per every 20 miles. So then you had to find it per mile, and that was kind of difficult. So this 8 here is like $1 for each cap. So it's $1 per cap. This is just money. And I obviously just want my cost to be money as well. So since 8 is dollars per cap, I'm multiplying by cap. So times cap, cap over cap, cancels, and I'm left with dollar bills, y'all. So that's a way, if that made any sense to you, I like to use that idea. If that's kind of confusing right now, stop thinking about it. And then maybe come back to it a little bit later. Okay. So how much would 225 caps cost to produce? Also, if nothing makes sense, I'm so sorry. Please email me because I'm so sick and it's 9 o'clock. Oh gosh. Okay. So we have function notation now. So if I want to find how much would 225 caps cost, I could call that C of 225 because I know what X is. It's 225 plus 8 times 225. Right, so that'd be 500 plus, oh golly, I don't know. Oh, I had TikTok open. 1800, which would then give me 2300 or 2300, right? And so over here we can say, if you wanted to, you can put your dollar sign right here, or you can to the side say this amount and box it. A thing that you guys were doing on your exams is so many of you would like circle like 4 different answers on a problem, or like have a work somewhere and have things boxed, but then have like a very neat place to put all your answers and they'd be different. So just try to be consistent and just mark one thing as your answer. I have to take points off if some of the answers you think are right are wrong. Okay. Oh God, fireworks are starting. Okay. So that was the cap problem, right? The difficult part was finding the model. I think plugging it in was pretty easy, but I think something to find out like, oh, that doesn't make sense. That wasn't enough. Is if it got under $500. Like, oh, that's something weird. I like did something wrong in my thing. Like, I'm buying over 200 caps and I have to pay at least 500. So why am I paying like under that? Right. So that's like somehow you can reason with the problem, be like, that's not right. If you get something crazy like that. All right. This one's a little difficult. So this is kind of what I was talking about, the unit conversion. So the average US resident uses 650 pounds of paper a year. Oh my God. So each person uses that many pounds of paper per year. So the average pine tree produces this many pounds of paper. Okay, let me highlight my things. Okay, I like to highlight all the numbers. Pounds of paper per year, and maybe let's attach US residents to that. And then a pine tree produces that many pounds of paper. So find a model for the number of trees used for paper in 1 year by ex-US residents. Okay. So if there's no people, how many trees are going to be used? None, right? So let's call this like T of X, right? Or what did I call it later? Yeah, we'll call it like T of X. Is this going to be something times X? All right. Since if there are no people, no one will use paper. I hope that makes sense. Okay. So now we need to find this B thing, right? So this is kind of where the unit thing comes about. So I want to find a model for the number of trees used for paper in 1 year. So this is trees per year, right? Number of trees in 1 year. This is people, PPL. And then, so B should be, right, trees per year per person, right? But I don't have ever trees per year. I have pounds of paper. Oh my God, so much unit conversions, right? So if each person uses, I want to figure out tree per year. So I know 650 pounds per person. And then there's also 4,130 pounds per tree. So pounds are going to go away if I divide them. If I multiply them, I'm going to get pounds squared, and that's bad. So I want something that has these type of units. And you can also think about it as, okay, if I am going to use 650 pounds and a tree uses that many, that's more than what I'm going to use. So I'm going to use a fraction of a tree. What's that fraction? It's 650 over 430. That's how much of a tree one person uses every year on average. I think that makes a little bit more sense than the unit thing I was saying. All right. So it's on average, that's how much of a tree each person uses. Then that's going to be my B. And we can take off a 0 too. So it'll be 65 over 413 times X. And that'll be what I want. Okay. So in 2003, the city of Cleveland Heights in Ohio had a population of 49,000. So that's 49,000 people. How many trees did Cleveland Heights use in 2003? So I'm going to plug. And it told me per person, not per 100 people, per, so whatever. So I just can directly put in 49,000. So what I hope I said earlier, 65, 49,000, and that'll be approximately 7,693. And it says how many trees, so it just gives me my units, so trees. Because I'm already given a year, so I'm assuming that's how much on average I use every year, so I don't have to do anything else to that. Okay. So most standard, it'll be like, what is this function? Okay, what happens when I plug this in. Okay, what does that mean? Something like that. Those are the type of problems that you'll be given. Oh, I love farmer ones. I'll tell you what my favorite ones are. My favorite ones are the ones that you guys get on your homework. I love those. They will be on your exam and your final. So a gardener waters his vegetable plot using a drip irrigation system. Ooh, also draw pictures. I know it might be silly, but like draw a picture. Especially with the farm ones. Water flows slowly from a 1,200 gallon tank through a perforated hose network to keep soil appropriately moist. Okay. During the spring planting season, the gardener requires 80 gallons. Oh man. Someone had not proofread this. Of water per day. Okay. So find a model. All right. So I have that much in my tank. And I'm going to use 80 of those gallons every day. And we're not doing physics here, so we're just assuming everything kind of goes at a steady speed. It's not like at some time or when he's moving. Don't care about that. Find a model for the amount of water that is in the tank X days after it's been filled. Right, so I'm gonna draw my tank. Okay, I filled up, right? So day one, I'm gonna have 12,000. So it's days after I filled it. So on beginning of day one, what time? This is the hardest part about when we were dealing with time. We're clicking our start watch right then and there. So this is going to be at x equals 0 when it's all the way up. All right, and then I'm going to use 80 gallons per day. So at the end of day one, and also at the beginning of day two, so like midnight, right? It's going to be 80 gallons less. So it's going to be like 1120 at x equals 1, and so on, like that. Oh God, I have to do 40 at x equals 2, and da 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 until we get here. So let's call this, usually I would ask you guys your favorite letter, but let's do G for gallons. We're already given that our variable is X. Okay. So we've kind of only been dealing with linear models, right? So A plus BX, right? Well, at time 0, our initial value, what's that going to be? It's going to be that 1,200 right there. So I'm going to have G of X of 1,200 plus B of X. So now it's going to require that I use 80 gallons per day. So, oh my gosh, my nose is runny. Because of that, for this B, I'm using 80 gallons. So I'm taking 80 gallons away. So it's B isn't going to be 80 because then I would be adding on to it. So I want B to be negative 80. So that makes G of X 1,200 minus 80x. And I kind of want to see, this is especially when I want you guys to show your work. I want to see these thought processes that you're happening. I'm sorry if me touching my nose is annoying. I want to see these thought processes because sometimes on your exams, you guys are like, doo, 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 and I'm like, I could do that in my head kind of, and I couldn't even do that. And so I really want to see your thought process on here and like a picture or something. Okay, give me something. Don't just write an answer unless it states otherwise, right? So how much, okay, great. So this is our thing. Let's block our answer. So how much water is in the tank after 3 days and after 12, all right? So after 3 days, this would be 1,200 minus 80 times 3. What is 8 times 3? I'm in elementary school, I had to stay after school to learn my 8 and 7 tables because I'm so bad at them. Okay, 3 times 9 is 27 minus 3, 24. minus 240 equals 960. Give me, yeah, 960. I also have it over here. What am I doing? And don't forget that we always need our units. Let me just put gallons. We don't have to necessarily write in like complete sentences. But definitely always have your units. And then at 12, we're gonna have 1200 minus 80, 1200, which is gonna be minus 960. Count was for some reason a lot easier for me. 240 gallons. Great. So after 3 days, I have 960 gallons, and after 12 days, I have 240 gallons. Great. So now we're asked to go a little step further. Oh, apparently I called it W earlier. We're calling it G now. We're going to interpret what G of 20 means. So now we kind of do need to add on a complete sentence, right? So complete sentence. So you're kind of explaining the problem with units in a sentence. That's what interpret means. All right, so first let's find G of 20. It's gonna be 1200 minus 80 times 20, be 1200 minus 1600, I believe, which is negative 400 gallons. Okay. So realistically, I can't invert the tank and have another extra 400 gallons. That's telling me I don't have 400 gallons I'm in the tank to make it that far. So the way we can say that is like the tank is, we can say 400 gallons short, or for us to make it to day 20, we would need another 400 gallons. But something just to really iterate that it's a negative value, right? So we're 400 gallons short of being able to water the garden for 20 days straight. We can even say something like that. Okay. And that's where it comes in practice, is getting better at phrasing these things. Something that's kind of fun is being able to teach what you're learning to somebody else. So like if you're able to teach like your roommate or your parents or something, and like be like, okay, does this make sense? Like if I say it like that and they're like, oh yeah, like that's what negative 400 would be. Like it might be good to talk to someone, or even just come to office hours with me if you want to. Don't know why I didn't think about that. I'll be there on Wednesday. Hopefully I'm alive. So that might help you interpret like what these things are supposed to say, right? Okay. So now we've talked about how I can make a model, plug numbers into a model. After plugging into a model, talk about what that means. And now I can do the opposite, right? Of that. So how many days will it take for the tank to empty? So that's not going to be 0, right? X is my number of days, and it says how many days. So that means I want an X value. When the tank is empty, that means when T of X equals 0. Or what am I saying? T, gallons, G. G of X equals 0, okay? I don't want that. So then, I want to find when G of X equals 0. So that's going to be 0 equal to 1200 minus 80x. So I'm going to add 80x to both sides. So I have 80x equals 1200. X is 1200 over 80, which is the same as 120 over 8. Oh, golly. So sorry if that is so annoying. Okay. Which equals 15 days. And don't forget your units. Okay. So my little nose is so sore. Okay. Okay. So that's how long it takes. So it takes 15 full days. And that's if he just runs it till empty. But if you've ever driven a car, you don't really ever want to go on empty, right? It doesn't come out, especially when you're watering, your water might not come out all the way. Might get stuck at the bottom, right? So the gardener prefers not to let the tank empty completely. Instead, he decides to refill it when the level has dropped to 200 gallons. After how many days should you fill it? So now we're not talking about when g of x equals 0. We're talking about when g of x equals 200. So we're going to do the same thing. But now we just have 200 over here. So now we can subtract 200 onto this side. We can add 80 onto the other side, just kind of keeping everything positive. So I have 80x equaling 100. No, sorry, 1,000. So x would equal 100 over 8, which is going to be 12.5 days. So like noontime, going in for lunch, he'll go and change the water on the 13th day. Yeah. So after 12 and a half days have passed. Okay. I think we have. Sweet Jesus. Okay. So now we're going to get information from the graph of models. So I think this is our last problem. Okay, thank God. I'm just sick. I want to watch The Bachelorette. So this is my favorite problem. This has been my favorite problem. Okay, well, not this one, but like something with fencing. Has been my favorite math problem since I was, how old was I? 16. And I'm 26, so 10 years. So the last decade, this has been my favorite math problem. So I'm very excited to share it with you guys. And the reason that we're doing it from graphs is just to, again, to reinforce what we talked about, like getting max and mins from graphs. And also because we don't know a lot of calculus yet, and that's how we can kind of learn max and mins. But right now, since we are going to be using graphing calculators, and the Desmos one specifically, we're going to be able to use the graph and stuff and use those little points like I taught you guys. So if a gardener has 140 feet of fencing to fence in a rectangular vegetable garden, okay, so my artistic skills get in. So our vegetable garden, and I moved into this. Okay, act like that's a rectangle. I tried to have an herb garden and it didn't work. All right, so like these are our little vegetables, our little flowers. Ooh, that's them. All right. And all around them is like our fencing, right? You want your deer out. You don't want any like pests or anything. Border them in, right? Act like that's some type of shape. Oh, Jesus. Okay. Putting too much time into this. I just also want you guys to love this problem. Okay. So it's a rectangular vegetable garden. So I'm getting rid of this fence because I hate it. Oh God, fucking fireworks. What that means in a rectangle is the opposite sides are the same length. In a square, everything's the same length. But in a rectangle, it's the opposite side. So like this is X, and Y. You can also call it L and W and stuff like that, right? Let's call it length and width because that's kind of, it makes more sense. So length and width. So this would also be length and this would also be width. Um, so sometimes especially in these graphing problems, you're going to be given two equations, especially when you're given two variables, length and width. I don't know. We don't know how to do anything with more than just one variable. So what's going to happen is I'm going to give something that I want to measure. So I want to find a function that models the area. Great. There's always two equations that go with every shape. Area and perimeter, and if it's a 3D shape, volume and circumference or surface area, right? A square, it's called a cube, it's called surface area. So we're always given two. And what I'm going to do is I'm going to take one of them, I'm going to have set. So right now I have that much fencing. That's going to be it can't be my area. It's going to be my perimeter. And the reason I also know that it's not my area is going to be some feet by some feet. So that's feet squared, right? Like, well, an acre is feet squared. But if you think about, like, if you look for apartments or houses, you're looking at square feet. So that's what we're talking about. That's an area. But if I'm just talking about how long the room is, that's going to be just feet. So that kind of gives you a hint of what, if I'm talking about a perimeter versus an area, and then if I'm talking about a volume, it's going to be cubed. So if you think about a square feet, that's like on the plane, and then a cube, that's a volume. So it kind of goes from there. I hope that made sense. So this is telling me that my perimeter is going to be 140 feet. Well, if I call one side length and one side width, I know the perimeter of a rectangle is 2 times the length plus 2 times the width. I just add up all the sides, right? And that's going to equal 140. The area of a rectangle is length times width. I think that one's pretty self-explanatory. But I only know how to deal with functions that have one variable, right? So, wait, let me say. I can only have one variable, not carryable, variable. There we go, variable. Going hilarious. So what I'm going to do is I'm going to take the function that is set, so it's equal to something, and I'm going to get one of my terms in terms of the other. So what that it's going to look like is 140 equals 2L plus 2W. Let's subtract 2L. So I get 140 minus 2L equals 2W. All right, so divide by 2. And I'll get 70 minus L equals W. Okay, great. So then I'm going to bring that up back to my area. Instead of length times width, I'm going to have that area is going to equal length times what I have for W, 70 minus L. And if we wanted to, we could distribute and do 70L minus L squared. Both of those are very good answers. Okay, so that's how we got to model area using one of the sides. If it gives you a picture and shows you what X is, and we'll do that on one of your homework problems, you don't have to choose which one's X and which one's Y. I don't specifically tell you that. But for this one, it doesn't really matter which L and W are. Okay. But most of the time it will matter, so just be careful. All right. So, so what range of width is the area greater than 525 feet squared? Okay. So we could also call area, if you solve for L, if we like, this would also be like 70 minus W equals L. So that could also give me that A equals 70 W minus W squared. So maybe read through all the questions. Not maybe, absolutely read through all the questions of each problem so you know which ones you're going to be looking for. Okay. So what range of width is the area greater than 525? So I want to know when 70W minus W squared is greater than 825. And on exams, if I want or homework, I'll specifically say that I want you guys to do this by hand and not a graphing calculator. And we know how to do this. This was on your exam. We want to find when 0 is less than 825, just moving everything plus W squared, right? So this would factor into W minus 15 and W minus 55, or you could have done the quadratic formula to solve this. So that means when W equals 15 and W equals 55, right? So I'm going to draw my number line. A lot of you guys on your exam just stop there and you're like, it's in between those numbers, which it isn't always, right? So it's not always just going to be right in between those numbers. And you also need to prove it's that one, and then you also prove that it's not the other ones, right? So we have 15 here, we have 55 here. 55. And now we're going to test. So my width can't be below 0, right? So I'm going to be between 0 and 15. Oh, and I could include 15 because it could equal 0. 15 to 55. And 55 to, what else would it be? There's a greatest one that we can find, but we'll just say infinity for right now. Okay, so I want to find when these things are less than or equal to 0. So let's plug in x equals like 10, x equals 20, and x equals 60. So this will be, I would always plug it into the factored form because it helps make a lot easier instead of doing like 70 times something. So 10 minus 15, negative 5, minus 55 would be negative 45, which is going to give me something greater than 0. A negative times a negative is always positive. Okay, for 20, this is going to be 5, negative 35, so that's going to be less than 0. And then for 55, minus 15, oh, so 60, it's going to be 45 and 5, so that's also greater than 0. So that one is our winner. So I would say either 15 to 55, or you could say 15, something like that. Keep your variables consistent, right? If you put an X right here, what's X? I don't know. X is never defined. W is defined. So be careful with that, okay? So that's how much our width is going to be for our area to be greater than that much, okay? So can she fence a garden with the area of 1250? All right, so 1250 is going to equal 70W minus W squared. All right, well, we can call that W squared minus 70W plus 1250 equals 0. Remember how I said if we don't always going to factor or we can't really factor nicely, it's our best bet to do the quadratic formula. So we would get like W equals negative B plus or minus the square root of B squared minus 4AC all over 2A. But it asks us if I can fence. So this is a yes or no question, not when and like how much X could be. So we really only need, so we are asked if we can not where x is. So we're gonna think smarter, not harder. So we just really need to know what I need to know if the discriminant, right, b squared minus 4ac, I need to know if that's greater or equal to 0. Because if it is, I have a real solution. And if it's not, I have an imaginary solution. And I can't imagine a garden. I mean, I can, but like I can't make an imaginary garden. I would look like a crazy pants. So I just need to see what this is. So what is this? 4,900 minus, oh, I feel like this is 5,000. That's the vibe I'm getting from it. Someone double check for me. If this like records wrong, I'm gonna be literally so upset. No one emailed me. Okay, yeah, good. It was 5,000. So we're left with a negative 100. Right, so it's less than 0. So we would say no real solution. There's a solution, it's just not real. And I don't care about that solution. Stop giving me imaginary numbers in your answers. I don't care about them. I do. I really like imaginary numbers, but I want to know that you know that that means we have no real solution. I need to know that you know that connection. So no, she cannot. Okay. So now we're asked, if it was a real solution, then yeah, we could have that garden, right? So what that graph is kind of looking like is I have like something like this, and then like 1250 was up here, and I couldn't ever obtain that. And that's why I don't have a real solution. These guys don't ever equal. But now I want to find this biggest part, right? If I know I can't have 1250, well, how big can it be, right? So we don't know calculus yet. Earlier we knew how to solve nonlinear dudes, but now, and we knew the quadratic formula, but now we don't know calculus. So we're going to use a graphing calculator. Right? So let's pop over to, there's Winston, Desmos. Oh my God, this is all from last time. So it was like 70x. Oh, I need to say y equals first. Y equals, oh no, not there. Oh geez. Y equals 70x minus x squared. You're like, oh, Mackenzie, that's a straight shot. Remember, we need to zoom out because we just saw that we can, well, we're only not hitting 1250 by 100. So I need to zoom out. There we go. I'm going to click, and it's giving me these nodules, but it's also giving me that top one right there. So I really only care about the top half of that picture because the bottom half doesn't exist to me. I can't have a negative area. That doesn't make sense in the terms of a real world. You look at an apartment and it's like negative 1,200 square feet. The heck does that mean? Am I living in someone else's house? So let's crop this bad boy because we don't care about down there. We only care about up here. Maybe we can make this a little bigger. Okay. So we find the dimensions. Another thing you need to worry about these problems is what is the question asking for, right? Like the one earlier was like, can I do it? Yes or no. So the answer was just no, not x equals something I, right? Like that wouldn't make sense. Like, hey, do you want to hang out? 3 plus 5i. Like, what? That's not an answer. So now we're asked to find the dimensions. So dimensions are, you just state which each variable are, right? Length times width times height, and so on, like, right? Those are dimensions, okay? So we did this for W, right? So W would equal 635. And what would feet, don't forget your units. And then what would our length be? Remember that length is 70 minus W. So your length would be 70 minus 35, which equals 35 feet. Oops, not 3 feet. That was crazy. It'd be 35 feet. So our dimensions would be 35 feet by, just draw a little X, 35 feet. That's usually how I would prefer for them. Oh, sorry, you also need to state the area. Sorry, 225 feet squared. There we go. Oh, I need to cough. I'm so sorry. So, I'm just kind of stating everything, right? So at these dimensions, this is our maximum height. I will be more specific about what I want. The textbook sometimes just like assumes that you know that you would give all of them. I see dimensions as length times width, and then I would be like, what's the maximum area? Okay, and the dimensions. That's how I would phrase it. What's the maximum area and its dimensions? Then I would want the area. Area is this feet squared. Remember, you get the units right, and then the dimensions are this by this, and that's what that little x means is by. Okay, so that is the end of this section. Thank you so much for dealing with my sick self. And if you have any questions about this is homework that is going to be due on Thursday, the 8th. So I'll be in office hours on the 7th from 3:30 to 5. But if that time doesn't work for you, email me. I just have a meeting at 2 on Thursdays. So just email me and we can talk about these problems because they're my favorite and I love to talk about them. Okay. So I will see you guys then. Goodbye.